We will go from 2 to 3:30, maybe finish a little bit early. Not sure about that, but we'll try. This particular communication pathways will be on the telecommunication kit. And if you have not yet received your telecommunication kit, your coordinator has it in his or her possession. So just a couple of things about the logistics of launching this curriculum. First of all, it's important for you to know that you will need to wait to hear from me to get the go-ahead on actually using this curriculum and program. The curriculum contents, the kit contents, have a number of safety and security concerns that we have to make sure that we navigate appropriately. Each kit is approximately 10 hours of instruction. It comes with its own curriculum, and it is designed to be STEM activity and embedded into the core content areas. So it is designed to be implemented by content teachers. And to that end, I need to have a conversation with DYS Director of Education and the Associate Directors of Education, just to make certain that they are aware of the curriculum that we're launching. And we have a communication protocol that we will follow, which entails the TC and teacher who will actually be implementing this. The TC will reach out to the coordinator with a specific instructional plan, and then the TC will reach out to the program director to ensure that everybody is on board and aware of the materials that are going to be launched in the classroom. When you receive the kit, please do not bring it up for instruction yet. Wait for my go-ahead, and we will work closely with you in the coming months to make certain that you get a chance to launch the kit materials and program. To that end, I will point you to Bill, who is going to really take us through the telecommunications STEM kit and talk about how it can be implemented in core content areas. So probably two parts to this, Bill, which would be a review of the curriculum and then a review of the actual contents and how to put it together. So are there any questions from anybody up until this point?
No.
Coaches are not getting a kit. Only the regions will receive a kit. So the deployment of these kits is very strategic. They are designed for short-term programs, meaning detention and revocation. That said, they can be used in treatment programs. So that is going to be up to you and your regional education coordinator. But if you are flagged for this training, it probably means that your regional education coordinator has targeted you as someone who is eligible to teach the kits. Does that answer your question regarding coaching? Okay. So Bill, I think at that point I'm going to turn it over. At this point, I'm going to turn it over to you.
Yes, ma'am. We will definitely work with for the next several sessions on the CPS program. I'd like to say thank you for being customers, and as we investigate the Communications Pathway series. As I understand it, you have not started the programs yet. Is that correct?
That is correct. They will not. Okay. Just to give you some context, some of these folks will choose to participate in the December training, and that will be a face-to-face training during specialized. So the goal of this webinar is really to just familiarize people with the STEM kit and to give them the opportunity to spend time with it and to read the curriculum and to develop an instructional plan with their coordinator.
Okay. Okay. Well, I would certainly step through all the programs, special emphasis on the starting the beginning program. So we're doing another webinar next week, which we could probably focus more on on specific programs, the telecom and the mission breakout, which would be the first two. Would that seem to work?
The next webinar will indeed be on mission breakout.
Okay. So
the strategy is three. Bill, the strategy is 3 introductory webinars. First one, telecommunication. The second one, mission breakout. And the third one, I forget off the top of my head, but it's the third one in the sequence. And then those 3 kits will be reviewed during the specialized face-to-face.
Okay. And then we also have an on-site professional development that's due the week before, the same week as Thanksgiving, right?
That is the specialized face-to-face, yes.
Okay. All right.
So
okay.
For today's purposes, we are only interested in the telecom kit.
Okay. All right. And then we can we can look at that again next week, and then we can check it out and keep going. Does that sound like a plan? So, okay, I will start. Once again, thank you all for participating in this. We appreciate you as customers, and we would do the introductions. I have everyone's names, and of course, Laura will have everyone's locations, and we'll get that straightened out as far as who we are. A lot of this is going to depend on input from all of y'all, and as how you see the programs as you're going through them, especially like Laura said, with the tools and the curriculum. A lot of the curriculum is pretty well laid out. We have fundamental lesson plans and supports that are in the instructor manual. There's also several movies and supporting movies. For that, we provide PDFs. If you want to reuse the manuals, we have the PDFs that were sent to you as well for worksheets and things like that. And then at the completion of the programs, of course, the students would get a certificate of completion, and that's done by a PDF that's printable by the instructor. There's a strategy for the activities and for the scoring, but then again, at the end of the day, it's up to the teacher as to what they think about how well the students got through it. And like it says here on bullet number 4, we're going to collectively and collegiately refine some of our methods. And in addition to that, I'm going to send you all a link for how to deal with our programs with middle schoolers. It's not up on YouTube yet, but it's going to be up on YouTube. And that would be something you could look at as well. A lot of great ideas, and the movie's about 45 minutes long. Okay, so we established that you haven't run yet, and then we're going to do in-depth discussion as we go through these professional developments and share our insights and delivery methods as we go through them. We could review the programs that we have previously done, talk a little bit about where you were at, what challenges you might have found, or what solutions, or what we can offer to fix, not to fix anything, but to supplement whatever thoughts you might have. Like we said, sharing instructional insights and delivery methods. Okay, so we pretty much covered this, and then we'll get your feedback as we get rolling as to other ideas and concepts that you might find valuable in these PD sessions and in regards to the CPS program. Okay, here's an example of the supports. Each of the programs is going to come with a flash drive that's going to have the activities, the movies, and all the supports like that, the activities, like I said. Inside of the instructor manual, you can see there that there's recommended for the teacher a rough lesson plan as to concepts that would be discussed. And then you have the program assessment. There's a grading structure there, and then how to do the certificate of completion. And once again, that certificate of completion is on the flash drive, and that'd be fillable by the instructor. Okay, and then here's Telecom Evolution. Once again, we put 4 students on one of these cases, and we put 2 students on a device. The big reason for that is because we want to develop some communication skills and have them work collaboratively with the programs and the tools. You can see right there is the tools. Okay, we have in this course, the students are going to make a 2-pair cable, and they're going to use the crimper cutter with that. And then, of course, they're going to basically build a telegraph. They're going to wind a electromagnet and build a telegraph unit. These telegraphs, if you'll notice, there's a data port on these, and these are, you can communicate with the 2-pair cable, with the telephone cable that they make to send messages back and forth.
So Bill, could I just interrupt you for 1 minute? First of all, just to clarify for teachers that are attending, you do not have to have 4 students to activity. If you only have 1 student that you're doing this activity with, or 2 students, that is fine. And that means that you will not need all of the contents of the kit. So you will be able to judiciously choose what contents you need for a cohort of 2 students or 1 student. So all of the kit contents looks a little intimidating, but you will not need all of that in order to implement with 1 or 2 students. And secondly, Bill, could you, when you're talking about building a telegraph, could you talk a little bit about the curriculum integrations that are possible with the actual building of a telegraph?
Oh, well, certainly. The entire process is laid out for you, and we're going to go through that. A lot of it is, parts control. They're going to be given different kinds of standoffs and screws and bolts and things like that. And, of course, we're going to step you through the entire process as to how that's put together.
Okay. I was just,
right.
I know that some of the teachers will be kind of interested to hear that there is for example, there's a history integration on the telegraph and the invention of the telegraph and how it, where we've come today with our telecommunications. And I think that with those integrated lessons, building a telegraph will make more sense to not only teachers but students.
That's correct. We're going to talk about the history of communications, what communications is all about. You can see on the current slide, that's pretty much what the focus of the course is on the telecom evolution. How the telegraph came to be and who invented it and that kind of thing. The history of the telephone is on there. What you're looking at now, this slide is when you see that icon, that indicates that they're supporting movies to support the process, not only in the text, but you have the videos as well. Okay, so just like we talk about back in the olden days that they used to run telegraph lines around the right-of-ways of the railroad tracks, today they do it with fiber optic lines. And believe it or not, SPRINT actually is an acronym that means Southern Pacific Rail. And that's what SPRINT's all about, using their fiber optic lines on the right-of-ways for the railroad tracks to provide communications across the United States. So there's some of the some of the movies that are in the program. I have the manual. We could just bring that up as well if we need to. Once again, you're going to have a lot of 2-pair cable. This is based on students' class size of 4, and then there's consumables there to allow you to run the course another 2 times. So that's what all the consumables are about. You can see here you have the little ends for the cables that would plug into here. And then, of course, we have in-depth directions on how to assemble the tabs as well. Here's your tools, your crimper and crimper cutter, and then you have the screwdrivers. And once again, anytime we're going to be dealing with cables or tools or anything, we certainly want the students to be wearing safety glasses. Set up a safe lab procedures. Does that all make sense so far? I'm assuming go ahead.
You got 2 seconds, Brian. We quiet? What's that? We quiet? About 4 or 5 minutes.
I'm sorry, I didn't understand the question. Laura, you seem to be coming in a lot than the others. Did you hear the question? Okay. I think for the next time, I think it would be better, instead of trying to do it on the web, is to call in also. That seems to help the communication process a whole lot better.
Well, have a good day. No. You want to do it? I'll take him up there. Shit, same here. You got a little bit of S right now. All right. Hang in here.
Okay.
There's shit going on all over. So.
No. Okay, I understand that you've all been familiarized with this program before.
Because they had a code.
I'm sorry, say again?
So you want to, anything you want to watch?
And Robert,
Yes?
could you please mute? Thank you. I'm sorry, Bill, and everyone else, please continue.
Okay. Well, if they have questions, we can certainly, there's a text box that you can ask questions with as well, and we can look at that. I'm assuming that most of these folks have completed the there was professional development that Howard did with these programs, and that was, you all accomplished that as well, right?
They have not. They have not. These folks may indeed be completely new to these kits.
Oh, okay. And the ones that were trained are not going to be running the program, or are they at a later date?
They are a separate cohort.
Okay. All right. Well, this is what the overall program looks like, and of course I can bring up the book and go over it. But these are some of the activities: encoding, encoding, and decoding, developing a code, communications. All the programs have a reflective practice, and we call that the I have learned. So there's at least 2 of these in each one of the units to stimulate not only conversation in the classroom, but reinforce what they've learned. And then Telecom Evolution, and then all the way through to testing, and then of course at the end of it we're going to have the careers pathways model. There's movies on most of the programs on how to find jobs and what some of the careers are out there, just to stimulate some thought on their future. Okay, here you go with the telecommunications process, right? The message, and it's transmitted through a medium, and it's received. And most of the time, like what we're doing right now, is the message is I'm transmitting in English. It's going through a medium, which is not only the air with the sound of my voice, but it's also going through the telephone lines or the go-to-meeting lines being received, and then you're decoding it as English. So we communicate through that. Okay. We get into the history of communications, from smoke signals to cell technology, basically, with a little bit on printing press, movable types, evolution of print, hieroglyphics, and then, of course, communication skills. Okay, you can see that all methods of communication require encoding and decoding, and it all has to travel through a medium, and we're going to basically go from communications through the air all the way through wires and even some wireless. Okay. Telephone codes, how to program your name into a phone. For example, mine would be 21 would be, I'm sorry, it would be 22. 2 for the B for these letters, and then 2 for the second letter, right? It would be a B, and you can do that. Of course, we get into codes and ciphers, and the kids can actually do their own code, the pigpen cipher, where they can communicate with symbols. The telegraph and Morse code, and how that all evolved, sending messages over long distances. And then this would be an example of how electricity works. Basically, on the top left up there, you can see where we have a switch. And of course, we have a battery. And when the switch is closed, we apply energy to a buzzer. And what that does is make a sound. And there's also a light on the board as well. So you have a sound and light. And you're able to transmit Morse code or a code of your choosing. You can see by the board here that we're going to have, this is the buzzer. And then the students are going to make the electromagnet over here, and they're given a series of wires, which they would connect the battery to the switch and then to the buzzer. It's all really pretty basic. Let me back up. These P's, P1, P2, P3, P4, relate directly to the pin numbers on the board, so they can see what they're doing as they assemble it. And there's a board just assembled to do a simple telegraph. But there's no key on there. It's just connected up. They still have to put the transmitter key on here, and if they choose to use the electromagnet, they can wind that, put that on there as well. This is your light. So you have a light here. When the system's activated, it also has a buzzer. And by configuring these pins here, with this information here, you're able to send it out over a 2-pair cable. Just like a telephone or just like a telephone would work. Here's an example of the parts. I would suggest that you look into the book. We have all the parts and the accountability parts list and what they need to assemble this. And you can see the parts are there on the right. You can put this together with the screwdriver, and it's fairly easy to do. These wires are all pre-made, so it's just a matter of unscrewing those terminals a little bit, right? Righty-tighty, lefty-loosey, opening that up and making a telegraph circuit. Here is your button that goes on top of the key. When they push this, it's going to activate the switch. And then this over here is your sounder. When it gets a magnetic field, it's going to tap down on the magnet to make the sound like an old-time telegraph. Here's the assembly instructions. Here's how you can bypass the switch and turn the unit on, make the buzzer go off, okay? And then they will assemble the key, basically the on-off switch. Just a matter of putting these standoffs on there, some long bolts, and a short bolt here, and then screwing those in on the bottom of the board, connecting these wires, and the system should work. Okay. Later on in the manual, they're going to wind a coil of wire to make an electromagnet, and then they're going to put the sounder on top of that, and then when that kicks off, it's going to go ahead and tap down and make an electromagnet. Of course, we're going to go into electromagnets and what they're all about, how they're used. These are still used today. Your speaker in your cell phone is a glorified electromagnet that just makes a diaphragm move instead of a piece of metal. We're going to get into the 2-pair color code because they're going to be making a cable. They're going to go ahead and put a plug on this like you would see on your telephone cord. And we're going to differentiate these wires by their color as to their function. Pairs of wires are basically into tips and rings. So you'll have a tip for pair 1 and a ring for pair 2. Okay, and you'll have a tip for pair 2 and a ring. Those are the designators of the different colors. Pair 1 would be one telephone line coming into your house. And if you had 2 telephone lines coming into your house, you'd use the black and the yellow. We use a mnemonic in this one. It's called Christmas Trees and Bumblebees, meaning that Christmas is red and green, okay, and that's pair 1, and bumblebees are black and yellow, and that would give you pair 2. So they're going to, of course, we're going to review safety and tool safety, and the students are going to strip the jacket on the cable. There's a little tab in there. It only goes so far, and you'll notice that those blades don't quite touch. That's just enough to expose the cable pairs. And all that does essentially is cut the white jacket off, and it exposes the 4 different color wires. And then from there, we would get a plug, an RJ11 plug, and put it in the crimper and crimp the pins down and make the connection. And it would look like this when it was complete. Of course, for all the constructions, there's going to be step-by-step movies that'll go through this for you. Of course, they're wearing safety glasses when they do this as well. Okay, here's an example when we want to activate these pins over here to send information over the 2-pair wire they just constructed. So this would be how those wires are connected, and they would make these connections, and they'd be able to send a signal to another unit, and it would go back and forth, just like a wired network. Here's the LED that lights up independent of what's going on here. This just goes to the other unit. Okay, so this unit could work independently by itself, or if you configure these, then you're able to transmit over the 2-pair cable. And there's a little thing called Ohm's law. And what that is it's going to talk about voltage, which in our case is a 9-volt battery, how much current and resistance are in the circuit, and the students are going to calculate, essentially given some knowns, they're going to be able to calculate how far those units can be apart and still operate. And what that comes down to is how long of a cable can you use and calculate. And they're going to calculate the time, transmission distance. Of course, there's movies on how to do this as well. Okay, and then that's the Telecom Evolution questions. And then we go into the other programs. I could certainly bring up a manual, and we could go through that if you desire.
I think that might be helpful, just so that teachers can see, if they do not have the manual in front of them, how accessible the curriculum is. Bill, that'd be great.
Yes, ma'am. Let me bring that up. We have, hang on, find it. Just if you see that airplane there, that's what I used to do in the Air Force. Telecom Evolution. Okay. Can you see the manual?
We can.
Okay. So the manual, so you can see that okay, Laura?
Yep.
Okay. So the manual is going to start out with an introduction and the things that are available for the course. Once again, we have a lot of hands-on. We're going to with the supporting videos and those things. Typically 8 to 10 hours in duration. If it's more, it's longer. Well, that's fine. You can always bring in additional materials. There's all sorts of web searches and things that can be done if you have that available to you. Okay, and then some of the key points. Okay, all the course objectives are going to be in the front of the manual. There's some of your supports. You can always call us. Of course, the flash drive is going to contain the movies and the supports that we talked about already. Here's your hardware, a list of hardware. Now, some of these things, if you'll notice with the star, are, here's a part number. After a few uses, you might need to order some more, especially like the plugs and things like that. And those are minimal costs for supplies for this program. The only thing that's replaceable really are if you can reuse these, and you can keep making these cables shorter. The only thing that you might start running out of is the RJ11s, but it's designed to run 4 times, so you should have enough materials to do that, at least 4 times. And of course, we have a warranty. It's good for 1 year. Your materials have never been opened, right? Okay. Here's the activities and suggested values for them, and it has a total point of 200 points. That's once again, that's up to the instructor. If you feel the students have semi-mastered or mastered the program, you can issue them a certificate of completion, which is a definite confidence builder. Okay, here's a way to track a tracking sheet for the instructor to track, and if you need, daily grades and things like that, and that's available for you. And once again, these programs are all cross-curricular, so we're going to bring in language arts, reading, science, history of science, mathematics are going to be all throughout these programs. Okay, we have the program overview, dealing with codes, and start out with dealing with codes in a telegraph, how those things all came about. Okay. The Telecom Evolution kit is the case that holds all the, and the TAP is the Telecom Activity Project. That's the board, okay, that they're going to be configuring. And they're all explained step by step. And once we get into the meat of the manual, you'll discover that. Of course, this is designed to kindle curiosity in science and technology, okay? Because and once again, if you all have any questions or concerns, by all means, let me know. Give me an email or shoot me a call. And then here's some of your basic lesson plans, some questions to ask as you step through the manual with the students, okay? We also show you when where it lines up with art, language arts, history. Okay, these are some prompts to get the conversation rolling with the students. Okay, printing. Okay, so we have these all the way through. In addition to that, when you couple these with the objectives, you can certainly throw you could put a lesson plan together. You can see throughout, and the books are roughly about 50, 60 pages. Okay. They're all the same in mode and method. Okay. You can see that. Is that too shaky for you? Or are you able to get a snapshot of what we're doing here? And then this would be where the student manual would start. Okay. Of course, here's your objectives. So you can see there's a lot in there, a lot of materials. And of course, major career paths. Okay. You will learn what telecommunications are. the importance of it, and of course we're going to define this icon. Anytime they see that in the book, there's additional videos or activities that support the concept. There's your table of contents. And once again, there's all your parts and a list of parts. And we're also going to give you in addition to the cable they're going to make, CTEC is going to supply you with a known good cable, so you can plug that in to verify operations, and then if it doesn't work, then you need to have the students look at their cables and try to figure out what they did, and then re-terminate as necessary. Okay, the evolution of communication, the communication process. This is the slide I showed you earlier. And then, of course, anytime we have new terms are going to be defined in bold in the text. They're going to be at the bottom of the page as well. Okay, or I'm sorry, they're going to be italicized, so they know what the new terms are. History of communications, first communication systems. Okay, these are some of the slides that I showed you already. Communications. Here's one. You look at this, and this is noise in the channel. You know, problems with communications. Okay, noise basically is something that's unwanted in communications. It can be anything from noise outside for a voice communication to a hair dryer for a phone, or anything that would make any kind of noise like that. An elevator motor, a fluorescent light. I'll make noise on data cabling, and that's where we're heading with those concepts. Okay, little history, symbols, hieroglyphs, printed records, okay, fonts, mail, Pony Express, and then we have a really good movie on the evolution of Gutenberg. Encode and decode. It happens all the time, right? And then, of course, give an example. Okay. Anytime this clipboard comes up, there's either a demonstration movie that the students would take notes on, or fill in a concept, or in some cases with a writing activity is explained to write the directions on how you would assemble a tap to go out over a telephone cable. Of course, this is the instructor manual. So you're going to have the prompts and the point values and all those things. The students would just get to demonstrate your understanding of the concept and explain the communications process. Codes and ciphers. A little bit of history. And then can do their own cipher. Telephone codes, how to write their name in the alphabet code. And then develop a code. Either develop one or use one that's in the book already, and explain that. And then when we get to telecommunications, then it's the medium of transmission is going to be fiber optic lines, copper lines, data networks, Wi-Fi, WiMAX, DAS communication systems, wireless. All those kinds of things. It all has to travel through a medium, but it's the same process. It's received, it's decoded, and the message goes to the listener. Okay, different types of communications as far as how data can travel to your home, either by Wi-Fi or WiMAX or coax or Fios or DHL. I'm sorry. Fios and DSL, right? And then, of course, there's a little assessment. Of course, you have the answers as a teacher. Okay, now we're going to get into the telegraph a little bit. We're going to show them what they're looking at when they build their key. A little bit of history before we get into that. Okay. The communication process through a telegraph station. And then, of course, we get into Morse code. Or the students will be practicing with that. How to write in Morse code. And basically how the ones and zeros of Morse code are the same as the ones and zeros that we use in data networks today. That's all it is. It's ons and offs. As long as the transmitter and the receiver understand the formatting and the timing, you're able to either send a telegraph message or you're able to send high-speed data anywhere in the world. Here's an example of a reflective practice. Okay, we're going to give 5 things that they've covered so far, and then we're going to ask the students to tell us a few things that they learned. And this would be an excellent discussion point. You know. A little bit about electricity and how that works. Of course, we're going to have a movie on this as well. Basic circuitry, basic flow of electrons. You can see here that electricity basically comes from the battery. That's a funky graphic right there. There it is. Through the switch. Touch the switch. It's going to complete the circuit. The light bulb's going to come on. Well, we do the same thing with the tabs, in that we're using a light and a buzzer. Okay. Here's a simple schematic of what they're going to be doing. Close the switch. Activate the buzzer. Okay. Close the switch, and then here it is with the pins that they're going to be connectorizing with the jumpers. Like I said, those jumpers are all pre-made. There's no crimping or anything you have to do with that. And then here they're going to they're going to examine the board and then go through there and assemble a simple communication system. You can see where we talk them through the whole thing. And then we're going to ask them to draw it. Okay, once again, we're going to talk about safety. Before we ever put any tools in our hands, we're going to get our safety glasses on, and we're going to talk about safety. And then we're going to assemble the board. This here is a piece of sandpaper. This wire has got that brass coating on it. The students have to sand off the ends a little bit to make the connection, to be able to put the electromagnetic on up here, electromagnet. And then we're going to show you, of course, the parts. Here's what you get. And then we're going to, now this is for part accountability and those kinds of things, right? Have them look at the parts, identify them, and check the numbers and quantities. Okay, we talk about there's no need to take these screws out, and then it's a matter of righty-tighty, lefty-loosey on loosening it up, put it in there, and then turn it and tighten it down. That's how you make the connections. And these are the connections right here, and what they should look like. And then it's going to be, okay, connect the jumper wires. If it doesn't have a 9-volt battery, then we supply those, of course, but you put the battery in and then it should operate. Oh, here.
Can you give us an example? Can you
An
give us an
example-
example of a device, a contemporary device that would have this system in it?
Well, any kind of communication systems would have it. When you, for example, when you push your key fob to lock your car doors, that's essentially what's happening at the car. The signal's coming in wirelessly, but it's an electromagnet that's keying a light and a horn. Anytime you switch a light on, you're going to be, putting energy somewhere. This picture here shows you that we don't have a switch, but if we put a screwdriver in between those two terminals, that we can make the system operate. It's like a car battery. A car battery needs to be in a car for the car to start. Your starter would be your key button that would activate the starter.
I just think it'll be important for kids to make those kinds of connections based on what they're putting together.
Well, they're looking at the flow of electricity, and they're taking something with hands-on, and they're assembling a communication system, a basic communication system.
Great, thank you.
Once again, there's the parts. Assembly, this is all process thinking, following steps, reading and completing an activity. And then we'll talk about magnetic fields, magnetic lines of force. Okay. For example, if you drive your car under you get your AM radio on, you drive under one of these things here, and you'll definitely hear the sound of the noise coming off of those lines. Okay. And when you get later on in data communications, that noise canceling is a very important thing to operate cell phones and data networks. The energy that comes off of these systems has to be negated. How magnetic fields and electric fields travel, and that's important in cell technology. Wi-Fi, it's all basically the flow of electromagnetic energy. Lines of force, this would be for magnets, magnetisms. The Earth has a north and south pole. Okay, navigation systems, GPS systems are all based on where you at, north and south. And then, of course, if you use a little bit of copper, you can take advantage of those magnetic lines of force and make things like electromagnets. So that would be like, latches for doors. If you have to buzz a door to get into an entry facility or something like that, that's an electromagnet. Okay, and now they're going to wind the coil and do the electromagnet after they understand magnets and electricity and how they interplay. And then they're going to have to sand just the very end of this before they put it into these terminals here. And when activated, that'll make an electromagnet and force that's not on there right now, but force that tab right down and make a clicking sound. Okay, here's what, now if they would activate this, the electromagnet would activate and pull this down and click across there. So they could see the effects of magnetism and electricity. There it is again, up close. Now you also, in addition to this clicking here, you also have a buzzer and a light that you can turn on as well to indicate that it's operating. Okay. And calculate, battery life, how long that's going to last. I'm sorry, telegraph is fun. What is this? I got a little ahead of myself. I should make it smaller. Okay. So like I said, it's the definition of the buzzer, the magnet, how it affects battery life. And then more on constructing, explain how to build a tap with an electromagnet. This was a writing activity where the student would actually explain this to, while they write the directions for another student to read and follow. And then we're going to get into a little bit about telephone, which is pretty much the same thing, except it's sound instead of magnetic clicks. It's through the telephone. Okay. Microphones, speakers. Now we're leading into them making a two-pair cable and how two-pair cables are applicable even today for telephone systems, and how those all work as far as generating tones and getting a signal from back and forth in the central office to operate their telephones. There's your two-pair cable. Christmas trees and bumblebees, and they're going to go ahead and assemble this two-pair cable, and they're going to connectorize their two, right? We saw that slide. I'm going to go through and with their show which pins are active on that, on the telephone cable, and then they're going to go ahead and assemble it. They're going to identify which collars go into which slot, which pin is hot. Okay, what it should look like when you're done. When you crimp a two-pair cable, you do two things. You actually take these brass tabs and you actually force those into the wire, and then you, back here, when you squeeze it, you actually take this little plastic tab and force that into the black jacket, and what that does is strain relief. So in case someone jerks it or trips on it or whatever, it shouldn't come apart. And then, oh, sorry about that. And then here's the assembly, right? The tool, you put this cable in here, right up to that tab, squeeze those together, pull it, and then it's going to expose the wires. And then that's what it should look like. And then we'll put our plug on there, and then we'll terminate it. Okay. Then they'll be able to activate the taps. Okay. Then we're going to ask them to explain how to make a two-pair cable. Of course, there's a movie on the construction as well. A little bit on Ohm's law. We talked about that. There's also a movie on how to, right there, calculate that. And then here we're going to have them assemble the tabs to activate the I/O port, the input-output, just like you have on your computer, and hook the two units together. And calculate how far they would go. And then at the tail end of it is the career pathways. Is that making sense so far? There's a lot of hands-on activities in making the tab. Okay, career pathways, some of the selection process. What if you change your mind? And then each of them has a unit review. And then all the new terms, vocabulary, everything they've ran across in the text is on the new terms, and then some ideas about searching the internet as far as reliable search engines to find key information. And then once again, here's the parts of the program, and then right here it shows you the SS102, which is it's basically the wires and the plugs. And then how to put it together again for the teacher. Does that make sense? Can I answer any more questions?
First of all, thanks, Bill. I think that as laborious as this may seem, for some of us who do not have that background, it's helpful. I just want to reinforce that the kits will be coming out to you as soon as we can get them deployed, and as soon as I have a chance to just make certain that the safety and security protocol has been vetted with the Department of Youth Services. And you will be receiving, in addition to the kit and the curriculum manual, you'll be receiving an instructional plan template, a communication protocol, and a safety and security protocol. And basically what that means is that before you can take the kit into your program, very similarly to green technology, before you can take the kit into program, you have to determine when it is that you're going to teach these kits, in what content area, or as a future ready activity during the reading block or during UIF. And then you have to present that to your coordinator. And then once your coordinator has approved the scheduling, then you will be able to reach out to your program director and review the safety and security protocol with the program director. I'll be very candid, this kit I'm a little nervous about because it does have a screwdriver. But you guys are so skilled at really making sure that you follow the safety and security protocol that I'm going to try not to worry too much about that. But please, with the telecommunication kit, be cautious of the screwdriver. Even if you have to actually do the screwing in of the screw and keep the screwdriver in your possession as the teacher, that's an option as well. But you know your kids best, and you know how much leniency you can use with those kinds of tools. The way that we're going to proceed from here is that I'm going to get Renee and Lisa and Katie's go ahead as soon as I can, and I will then dispatch those documents to you. The coordinator already has the kit in his or her possession. Some of them may have already given it to you. Have your kits, please do not deploy them yet, and keep them in a secure and safe place until you get the green light from me. And then be able to work on your instructional plan and meet with your coordinator to determine how to best implement the kit moving forward. Just so you know, I'm going to just really quickly again review the kind of the launch process. There are 7 kits in total. We're launching 3 this fall, and we're launching, we launched 1 last year that we'll be reviewing, and we're launching 3 in the spring. So if you are interested in these kits and you think that your kids will be engaged, I'd encourage you during specialized PD to sign up for the CTEC face-to-face training, because you'll actually be able to get support in how to use the kits, how to best implement them in the classroom. And face-to-face and hands-on is always a really much better way of training, I think, than a webinar. So again, David Bill will be with us at specialized training. So if you like these kits, the thought of these kits, and you're anticipating that you will use them in the classroom, I would encourage you to sign up for the CTEC specialized session. And with that, are there any questions? You guys have been wonderful. And I know it's the end of the day, so I really appreciate your patience. And I would entertain any questions. And if there are is anything that David or Bill could answer as well. Okay, I will also tell you that this session has been recorded. So, Bill, how do we get access to this session if people wanted to review?
You have to, it works through GoToMeeting, and then I'll get a link eventually as soon as it renders, and I'll pass that along to you.
That'd be great. If you could email it to me, I could dispatch it, or email it out to teachers for their reference.
Sure. And I also suggest that maybe next time we try to, instead of doing voice on the web, to dial in, because that seems to be work a whole lot better as far as being able to understand everyone.
Okay.
So, and we'll be doing this again next week, next Thursday, right?
The
17th?
17th, yes. And Bill,
Okay.
just for information, I will not be on that webinar, but Darnell Thigpen Williams, our Associate Director of PD, will be covering that.
Okay.
All right. Thank you, everybody. I really appreciate it.
We'll see you then. Thank you.
Take care.
Thank you, everybody.
This conference will now be recorded.